Hello, I'm Professor Sharon Robinson from the University of Wollongong, and I'm going to tell you about our new paper that's coming out in Methods in Ecology and Evolution about using drones to map and monitor vegetation in Antarctica. Antarctica is the coldest, highest, driest, windiest continent on Earth. A huge desert with lots of water, but almost all of it locked away as ice. The summer growing season in Antarctica lasts only a few months and is characterised by 24-hour days and temperatures ranging from as cold as your freezer, -20 degrees Celsius, to a bit warmer than your fridge, +10 degrees Celsius. In winter, vegetation has to withstand months of freezing conditions and almost continuous darkness. These harsh conditions mean that the vegetation is dominated by mosses and lichens that can survive frozen through the long winter and then desiccate and rehydrate and freeze and thaw all through the summer. These are really tough plants. Many are unique to Antarctica and have probably survived through periods when the whole continent was covered in ice. The important thing is that they can be frozen for many months or even years and then start growing again when conditions improve. We don't find flowering plants or trees in Antarctica because these plants all have plumbing to move water around, which would freeze under the Antarctic conditions. In their dried or frozen state, these mosses can survive for decades, green and ready to rehydrate and grow as soon as they get free water. They are found along melt streams and on the edges of lakes, where meltwater from snow and ice is available through the short Antarctic summer. Near the Australian Antarctic Casey Station, we find some of the most extensive and best developed moss beds in East Antarctica. Antarctic plants can be important indicators of subtle changes in environmental conditions, including climate change. In order to provide information to Antarctic managers on the health of these moss beds, we have developed a long-term monitoring system for ecosystem health. The challenge is to do this with as little impact as possible. Human footprints last a long time in an Antarctic moss bed. But how can we tell when mosses are healthy and growing? Greenness on its own doesn't work. We also need to know when the mosses are hydrated and actively growing. We are using drones to fly over the moss beds and collect spectroscopic data reflected off the mosses. This gives us moss health indices in real time. We combine a greenness index that shows how much chlorophyll is present with a leaf texture index that shows how wet the moss is. Using these two, we can see when the moss is active and growing, blue in this image, where it is stressed, red, and where it is so dry it has stopped growing. Traditional ground-based assessments of vegetation health are not ideal as they can destroy the vegetation and are often physically demanding given the harsh Antarctic weather conditions. We have shown that drone-based monitoring of vegetation health produces similar results to traditional techniques, but with much greater efficiency and with no damage to the vegetation. Drones equipped with sensors can detect these important vegetation health indices more accurately than satellite imagery. This is because Antarctic mosses are very small and occur in patches amongst rocks and ice and soil, so the imagery used to assess vegetation health must be as accurate and spatially detailed as possible. While WorldView 2 satellite imagery produces images with individual pixels of about 2 meters, the new drone-based method produces vegetation health maps with individual pixels of 5 centimeters. We found that while both methods could provide accurate spectral information, the satellite pixels were just too big and too mixed to be useful with the patchy Antarctic vegetation. With our new drone-based method, vegetation health can be measured much more accurately because the pixel size is similar to the size of individual patches of Antarctic moss. This means we acquire pure moss spectral signatures and can determine how healthy these mosses really are. Drones are a cost-effective method of mapping vegetation health in remote or dangerous areas and can be used even when full cloud cover prevents the use of imagery from satellites or aircraft. They require less time in the field and thus measurements can be repeated at more frequent intervals than traditional vegetation health monitoring techniques. Drones are thus a powerful tool for monitoring fragile Antarctic vegetation. They could be used to provide timely warnings about specific environmental stress events, as well as monitoring the long-term impacts of climate change. Our methods could also be adapted to monitor the health of other short stature or patchy plant communities, including in alpine regions, as well as across the Antarctic continent. The Antarctic Treaty states that Antarctica is a natural reserve devoted to peace and science. It commits all countries operating in Antarctica to protect Antarctica's living resources. With other Antarctic scientists from across the world, we're developing an Antarctic nearshore and terrestrial observing system, which will help to preserve Antarctic ecosystems in as pristine a state as possible for future generations. If you want more information on this topic, please read our paper in Methods in Ecology and Evolution. Thank you.